Did any of you ever have a neighborhood watch wherever you've lived or as a child? I think these are great. Basically, the idea is that citizens in an area would actually keep their eyes out during the day to make sure that if there's any mischief going on, they would notify the police. It's just kind of a pact, right? Okay, I understand the police can't be everywhere at all times, but I want them to be responding fast if there's a problem. So I'll tell them if there's a problem, and I'll keep my eyes open as to what's going on. And if anyone has any problems, they know they can come to me quickly. In the same way, I want you to think about radio resource management with our wireless LAN controllers and access points. It's a neighborhood watch. So that when devices out there recognize, ooh, this access point is gone, or ooh, we need to change what frequency we're using because of other devices that have come into play, we can dynamically fix those problems immediately. RF management. And it works its way through the use of RF groups. So our devices are going to work together as groups. Which devices? Well, again, the wireless LAN controllers. We can have up to 20 of those basically in a group together. And the access points that are out there being managed by those, up to 6,000 of those devices can actually have their RF signaling changed by virtue of the RRM group management decisions, right? The RF group working its way through the RRM service. This is associated with both CAPWAP and LWAP, so it's a backwards compatible service. It's been around for quite a while at this point. And again, it's now encrypted in release 7.0 MR1 for PCI compliance. That's good news. What's going to happen? Our access points are going to send and receive neighbor messages, right? That happens every 60 seconds. And it's a way to verify, okay, what devices do I see around me? And as we have overlap between those devices that are a part of the same, that are associated with the same group name, they will pass that information upstream to the wireless LAN controller that is associated also with that group. All right, so you've got a controller with a group, you've got access points managed by that controller. They have that same kind of inherited RF group name. Multiple devices hear each other that are managed by different controllers, possibly, will be associated with the overall cluster where we've got multiple wireless LAN controllers working together. Leadership is going to be determined. Just like the citizens don't, bust the criminals, we need to hand it off to the police, right? Well, the access points don't dynamically figure out what to do. They hand off the control to the wireless LAN controllers, and specifically, in many cases, to the wireless LAN controller group leader. So a group leader is determined amongst the different controllers, if there's more than one, who then analyzes the incoming information and will make decisions about things like DCA, right, dynamic channel assignment, or TPC, right, transmit power control. That leader will make those determinations. Interestingly, when it comes to the cover hole detection and configuration process, that's actually done by the local wireless LAN controller, not associated with the leader necessarily. But again, you see this idea. It's not the access points. It's up to the wireless LAN controller and maybe to the delegated or to the elected group leader, I should say. And that leader will then pass downstream the instructions on how to tune the specific access points that are out there. Those neighbor messages are sent every 60 seconds by default. Every 600 seconds, we actually have a polling process where we'll reconvene. Oh, so how should I change what I've done, right? How should I change my local configuration? That happens every 600 seconds. If a device is out of band, then it will be dropped after actually a pretty long interval. So you can be knowing that a neighbor is there, but after 20 minutes of not being there, then an access point will drop that device from the list and stop telling the wireless LAN controller that it knows about it. Because especially when you're on the periphery of each other, it can be difficult to maintain consistent levels of knowledge. Now, again, the access points will send upstream, pointing downstream here, but they'll send it to the central wireless LAN controllers that they're associated with, and they will send their top 34 list of access points that they have heard as neighbors. The wireless LAN controller then prunes off the bottom 10, it takes the top 24, and looks at the associations that are available to group them together and to, again, define power levels that need to be managed or that channel assignments that need to be managed. The election of a group leader, if we have more than one wireless LAN controller, can happen in one of two ways, dynamically or statically. So it used to be we only had dynamic assignments. Static assignments now have been assigned. You can just pick and choose the biggest, baddest, beefiest device that you want, or you can leave it up to dynamic assignment. There's a group ID that's associated with each one of these wireless LAN controllers. That it's associated with a counter value that changes over things like reboots of the wireless LAN controller and other things, plus a MAC address. So if you leave it dynamic, it has a method to determine it with basing it upon the highest MAC address if there's a tie in the counter value embedded in the group ID. And from that, it'll choose that group leader. Because somebody's got to make the centralized decisions that then are dispersed out to all the wireless LAN controllers, which are then dispersed out to all the different access points. So it has a system for managing that, ensuring that you always have someone in control.